Good day. We will solve a case involving scenario 1 when the price is varying. In this example, a company produces and sells a consumer product and is able to control the demand for the product by varying the selling price. The approximate relationship between price P and demand D is approximately P is equals to 38 plus 2,700 divided by D, where the condition is D should be greater than or equal to 1, where P is the price per unit in dollars and D is the discrete demand per month. The company is seeking to maximize its net profit. The fixed cost is $1,000 per month and the variable cost is $D per unit. The required: A. What is the optimal number of units that should be produced and sold each month? Letter B. Show the answer in part A maximizes profit. Letter C. What is the unit price of your answer in part A? And letter D. What are the break-even points in the range of profitability? Given is the equation P is equals to 38 plus 2,700 divided by D, where the condition is D should be greater than or equal to positive 1. P is the selling price per unit in dollar and D here is the demand per month in units. Other given are the fixed cost. It is equal to $1,000 per month and the variable cost $D per unit. We are going to find A, D, or the demand or optimal number of units. B is the total profit or profit. C, P is the price per unit in dollars per unit. And letter D, the break-even points and the profitable region. For A, we will use the formula TP is equals to TR minus TC, where TR is P times D and TC is equals to, therefore we will get TP is P times D from here minus TC, which is bracket C sub F plus quantity C sub V multiplied by D. Let's get first the TR. TR is P. P is 38 plus 27 divided by D. Multiplied by D by distributive 38D plus D will cancel, so this is 27 or 2,700. This is the equation for TR. For TC, TC is CF. The fixed cost is $1,000 plus CV is $D multiplied by D. We will get 1,000 plus D squared for TC. Therefore, TP is TR minus TC. We combine the two equations. TR is 38D plus 27 minus 1000 minus T squared. Combining like terms will give us negative D squared plus 38D plus 27 minus 1000 is 1700. To get its maximum profit, we will get the derivative of this equation and equate it to 0. So derivative of TP with respect to D is equals to derivative of this equation is negative 2D plus 38. And equating this to 0, negative 2D plus 38 equals 0. Negative 2D to the other side will give its positive sign. D therefore is T is equals to 38 divided by 2, or D is equals to 19. So in our graph, D is here. D is the demand needed to achieve maximum profit. Next, for B, we will use the equation TP is equals to negative 2D plus 38D plus 17. From here, this one, and then we just substitute D to the equation. Therefore, TP is equals to $2,061. So our profit when we produced 19 units will give us $2,061. Next, we'll compute for letter C. C requires us to compute P. So we will use P is equals to 38 plus 2,700 divided by D, where D is greater than or equal to 1. We substitute 19 to D, 38 plus 27 divided by the 19 units. It is $180.11 per unit. And lastly, our letter D, we will get the break-even points and the range of profitability. So we will use quadratic formula. X is equals to negative B plus minus B squared minus 4AC all over 2A. Using our equation, TP is equals to negative D squared plus 38D plus 1,700, and we equate this to 0. The A coefficient, 38 is the B coefficient, and C is the 17. We will get for D prime sub 1 is x equals to negative 26.40, or this is 0, and d prime sub 2 as x is equals to 64.4, or 64 in whole number. This is our break-even points. And the range of profitability is from 1 to 63. To better understand this, our d prime sub 1 is located here, and our d prime sub 2 is located here. And the profitability range is from here to here. Thank you very much.